Hello all. I just want to show you a video because some of you are asking me for some help for some of the homework questions that I gave you. Specifically question number 4, 5C, and 6B. Now, so for question number 4, it says the Ka is 5.59 times 10 to the negative 10 for NH4 plus 1. What ratio of NH3 to NH4 plus 1 must be present to give a pH of 8.810? Now, because they gave you a Ka value, so for question number 4, if I were to take a look at this, so this would be NH4 plus and H2O would be in equilibrium with NH3 and H3O plus. Now, because they gave you a Ka value, you know that that is a weak acid solution. So if you have Ka is equal to concentration of NH3 times concentration of H3O plus all over concentration of NH4 plus 1. So what you have is you have Ka over concentration of H3O plus is equal to the concentration of NH3 and over concentration of NH4 plus 1. Okay, you know what the Ka value is. Ka value is 5.59 times 10 to the negative 10 all over 10 to the negative 8.810, which is equal to concentration of NH3 all over concentration of NH4 plus 1. Okay, that is how you would solve question number 4. Now, question number 5C, it says you have 50 mils of 0.60 molarity N2H4 is mixed with 1 liter of 0.4 molar N2H5Cl. Now, the key thing is here, you have a Ka value. So they gave you a K value of 1.7 times 10 to the negative 8. So what that means is an easy way is you could write the equation plus 1 plus H2O would be in equilibrium with N2H4 and H3O plus. Okay, so because they give you a Ka value, what you can write is the equation produces H3O plus. Now, in this case, the ion, the N2H5, the ion from the salt is in the reactants, while the other substance, the conjugate base, is in the products. Now, you might say, well, Mr. Chan, could you have reversed it? Could you have done this way, where you have N2H4 and H2O would be in equilibrium with N2H5 and OH minus 1. And it would look similar to what you have up here. Okay? Yeah, it doesn't matter. But in this case, if you choose this equation, what you would need to use is you would need to use the Kb calculation. So you just have to do an extra step. So regardless of either way, both of them work. Okay? Now, so you can do a Ka or Kb, and I'm going to use it with a Ka value. So what I'm going to do is I'm just going to wipe out this question here. Okay. And what I can do is I'm just going to set up the ice tables like what we had done before. Okay. And what I'm going to do is I'm just going to do the dilutions real quick. So here is 0.4. Okay. So here I have 0.40 times 0.1 liter all over 0.15 liters. And for the N2H4, it's 0.6 times 0.05 liters, all over 0.15 liters. This will be 0. So if I did a quick calculation, times 0.1 divided by 0.15. So here would be 0.267 molarity. So 0.6 times 0.05 divided by 0.15. Here would be 0.2 molarity, and this one would be X. Okay. Now, what you could do is set it up and do the standard like here, what we've done up here for question number 4, set up the equation and then fill in the numbers. But the other thing is, remember, you could also use the Henderson-Hasselbalch equation or the rearranged equation. So you have H3O plus is equal to Ka times concentration of N2H5 plus 1 all over concentration of N2H4. Okay, so what you have here is your Ka value would be 1.7 times 10 to the negative 8 times, in this case, 0.267 divided by 0.20. And what I would get is 1.7 e to the negative 8 times 0.267 divided by 0.2. So I would get an H3O plus concentration of 2.27 times 10 to the negative 8. And I think the question was, what's the pH? Okay, so question number 5C. It looks like I got a wrong answer. So let's take a look. And then I get 7.64. So that was probably a wrong answer. Okay. Now, the last question would be question number, in this case, a buffered solution contains 2.5 molarity NH3 and 0.4 molarity NH4Cl. So if we were to do this question here, let me just do it so that we have space. So first off, for question number 2B or 6B, the HCl, remember, reacts with the base. So in this case, the NH3 will react with the HCl to produce NH4Cl, which is basically, you could break that apart to NH4 plus and Cl minus 1. So in this case, if you have 0.25 reacted with 0.1, so here you would produce 0.10, which means that you have 0.1 and 0.1 of the NH4 and Cl. Now, this, we're calculating what's reacting. So after reaction, the NH3 has decreased to 0.15 moles. Okay. And the NH4 plus 1 increased to, in this case, 0.50 moles. Okay, the reason being, again, if we look at the equation right here, the NH3 gets used up, okay, to react with all of the HCl. And what happens is 0.01 moles of NH4 is produced. Okay. So because 0.1 moles is produced, you are creating more NH4Cl. So it goes up from 0.4 to 0.5. Okay. And then the NH3, because 0.1 is used up to react with the HCl, you're left with 0.15. Okay. Now, I divide this by 1 liter, so we get molarity. Okay. So again, what we do in this case is calculate the pH of the solution that results. So what you could do is you could do concentration of H3O plus, okay, is equal to Ka times the concentration of, and in this case, I believe it's NH4 plus all over concentration of NH3. So here, what would be the Ka? Would be Kw over Kb times, in this case, 0.50 all over 0.15. I'm wondering if I have another wrong answer, but we'll figure that out. Over 1.8 times 10 to negative 5 times 0.50 all over 0.15. Okay, so 1. So I get an answer of 3.33 times 10 to negative 9. Take the log of that. I get 0.48. And 8.73. Ooh, did I make a mistake? Okay, let me quickly check. Probably. It's a 2 point. Yeah, I probably made a mistake. All right. So I got 8.48. Hopefully that's not too far off. Okay. So I might have made a mistake in my calculations, or in this case, I might have forgotten an extra 0.010. Try that out. Okay. All right. Thank you very much. Sorry for the errors. Okay. Hopefully, I've made some of the corrections and clarified a few things. Thank you very much. Have a good day. Bye-bye.